Part 2 of comparing fractions. In the first video on comparing fractions, we covered all the basic fraction ideas. Everyone taking the GRE should know those basic ideas. This video covers some very advanced ideas. And so some people are going to watch this video and say, wow, that's really cool. That makes so much sense. Other people are going to look at this and it's going to make no sense to them whatsoever. So if you're highly skilled in math, these can be time savers only on the hardest math problems that you'll see on the GRE. And again, you would have to be an advanced math student even to see the hardest problems on that second math section because the test is section adaptive. If you're struggling with math, you'll never see those harder problems. So this can be fun for math lovers, but if you're not a math lover, if you're getting frustrated by this video, you don't even need to watch it. You don't need to know this at all. And so it's something really only for the more advanced students. And so, of course, everyone is welcome to watch it. Get as much out of it as you can, but don't worry if it's over your head. So first of all, let's just review the basic patterns, the stuff that everyone should know. Make the numerators bigger numerators, you get bigger fractions. Make the denominators bigger, you get smaller fractions. Multiply the numerator and denominator by the same factor, you get equal fractions. And then, of course, you can compare numbers with cross multiplication. So those are the basic ideas. What if we add the same number to both the numerator and the denominator? So this is where the new stuff starts. What if we add the same number to the numerator and the denominator? Here I'm going to show an advanced technique, a visual technique, that allows for quick approximations. If we add the same number to both the numerator and the denominator, then the resultant fraction is closer to 1 than was the original fraction. And so if the original fraction were somewhere down here, less than 1, it would move up closer to 1. But if the original fraction were somewhere up here, larger than 1, it would move down closer to 1. So it's as if 1 is the great attractor and everything is moving toward 1 when we do this trick of adding the same thing to the numerator and the denominator. For example, start with 3/5. 3/5 is obviously less than 1. So suppose we add the same thing to the numerator and denominator. For example, let's just add 6 to the numerator and denominator. We get 9/11. Well, that resultant should be closer to 1. Since we started out less than 1, the resultant should be larger than it, closer to 1. So in fact, what's happened is the fraction has moved up closer to 1 as a result of adding 6 to the numerator and the denominator. So 9/11 is bigger than 3/5. Now start with something bigger than 1. Start with 7/4. And let's just say we add 1 to the numerator and denominator, 8/5. All right? So now we're going to move toward 1 again, but because it's bigger than 1, it's going to move down to move toward 1. So moving from 7/4 to 8/5, we actually move to the left. We move down. So 8/5 is less than 7/4. Often the real trick here is to recognize that this pattern is applicable in the first place. Once we see the pattern is in play, applying this rule is very easy and involves essentially no calculations. So pause the video, work on this, and then we'll talk about it. Okay, well, first of all, we notice, because we've been kind of set up by the discussion we've had, but we notice that this trick is in play. And essentially, what we've done is we've added 3 to the numerator and denominator. And because we're adding 3 to the numerator and denominator, we're going to move closer to 1. Well, this fraction, this initial fraction, 147 over 200, is less than 1. So if it's less than 1, moving closer to 1 makes it bigger. So 150 over 203 is going to be slightly bigger than 147 over 200. And so the answer here is answer choice B. What if we add something different to the numerator and denominator? How does the value of the fraction change? Suppose, for example, we add 2 to the numerator and 5 to the denominator. Well, now the great attractor is not going to be 1 anymore. The great attractor is going to be 2/5. and the resultant fraction will be closer to 2/5 on the number line than was the original fraction. So anything that starts out lower than 2/5 is going to get pulled up closer to 2/5, but anything that is larger than 2/5 is going to get pulled down closer to 2/5. Again, 2/5 now is the great attractor if we're adding 2 to the numerator and 5 to the denominator. So start with 1/8. 1/8 is less than 2/5. We add 2 to the numerator and 5 to the denominator, we get 3/13. Because we started out less than 2/5, moving toward 2/5 makes it bigger. And so this fraction has gotten bigger. 3/13 is greater than 1/8. Now start with 3/4. Well, 3/4 is bigger than a half, and a half is bigger than 2/5. So this is definitely bigger than 3/5. Now we're going to add 2 to the numerator, 5 to the denominator. We're going to get 5/9. Well, now we're going to move closer to 2/5, but because we're starting out larger than 2/5, moving closer to it will make it smaller. And so we actually move down. We move to the left from 3/4 to 5/9. So 5/9 is smaller than 3/4. In general, here's where we can abstract and generalize this now. Adding p to the numerator and q to the denominator slides the fraction in the direction of p over q on the number line. If the original fraction is smaller than p over q, then the result is bigger. If the original fraction is larger than p over q, then the result is smaller. And so it's all about p over q becomes this great attractor. You start out lower than it, you get bigger. You start out higher than it, you get smaller. If we subtract numbers from the numerator and denominator, we just get the opposite effect. If we add to the numerator and subtract from the denominator or vice numerator, then whichever fraction has a larger numerator and a smaller denominator is bigger. It just has to be bigger. Here's a practice question. Try to do this without a calculator. Okay. Well, notice a few things. We added 6 to the numerator and 9 to the denominator, so the resultant fraction will be closer to 2/3. Well, where were we starting? The starting fraction, 37 over 60, 37 over 60 is less than 40 over 60. 40 over 60 equals 2/3. So we started out lower than 2/3. We moved in the direction of 2/3. And so that meant that we actually had to get slightly bigger. And so it became slightly bigger, and so the answer is B. Here's another practice question along the same lines. Okay. Well, here we just added, this is just the first trick, we just added the same thing to the numerator and denominator. That means we get closer to 1. Well, 171 over 100 is bigger than 1, and so it must get smaller when we add 9 to the numerator and the denominator because it moves toward 1. And so it means that 171 is over 100 is actually the bigger fraction. Answer choice A. Here's a good word problem. Pause the video and then we'll talk about this. Okay. In this problem, we could set up all kinds of complicated ratios and use the calculator. We could make this a very hard problem, but it turns out it's a relatively easy problem. The old ratio, the original ratio, is 6 teachers to 200 students, or in other words, 3 to 100. And I'm going to reduce that to approximately 1 over 33.3. And then we're adding 1 to the numerator and 35 to the denominator, which is going to move everything closer to 1/35. Well, 1/35 is smaller than 1 over 33.3. Bigger denominator, smaller fraction. So adding 1 to the numerator and 35 to the denominator will decrease the ratio. And so it means that the old ratio is bigger than the new ratio, and the answer is A. If we start with a fraction and add the same number to both the numerator and the denominator, that resultant fraction is closer to 1. If we start with a fraction and add p to the numerator and q to the denominator, the resultant fraction is closer to p over q. And again, this is a very visual trick. It's a very hard trick to see and to apply. If it's something you understand, it will save you time. Don't worry. If this is something over your head, you will never need to know this.